Hello, guys. Welcome back to Maths Zone African Motives. We are going to consider a revision, which is preparing for the March test that we are going to write. So, what we are going to do is to work out previous question papers so that we can see and have a look on how they ask those typical questions and how to answer that. So this is Mpumalanga province, and it was a March test for 2025. All right. So we are going to use that one and see how we can attempt these questions. It was out of 50, and they wanted you guys to write this one in 1.5 hours. So you can download the question paper and the memo from the description of the video, or you can check in the comment section. I'm going to put a comment which you can use and download the question paper and memo. So the purpose of revision is to correct some of the areas that are there in the memo. So you'll find out sometimes there can be some errors. So this is the purpose of these revisions, for us to also take note of those errors, and also for you to understand how to answer these typical questions. So read your instructions before answering the questions. Read everything, all right, that you're given, especially that your answers should be rounded off to 2 decimal places, all right? So make sure you understand the question before answering. Question one, we are given on number one, circle the letter of the correct answer in the answer book provided. All right, 1.1. Which of the following is a natural number? So a natural number, we are referring to counting numbers. All right, we are referring to counting numbers. But on these counting numbers, we are going to exclude zero, excluding zero. That is, we are not going to include zero. We are not going to put zero. So zero is not part of natural numbers. When you talk about counting numbers, we are going to exclude zero on what? On natural numbers. So meaning to say, this is totally out. All right. So we have pi. Pi is not a counting number. This is a decimal, 3 comma something. All right. Let's see. Pi is equal to 3,14, and so on and so on. So meaning to say, that's not a natural number. All right. We are talking about counting numbers 1, 2, 3. All right. 4, 5, and so on. 25. That's a counting number. All right. Square root of 9 over 3. All right. 3 into 9. That's a 3. So we've got the square root of 3. Square root of 3. That's not a counting number. We cannot have this. That's 1,7. We do not put those ones as counting numbers. All right. So this one is totally out. So the best answer was going to be on B, 25. Calculate 2 plus minus 3. So 2 plus minus 3, that's, we are going to the left 3 times. So that's going to be -1 plus minus 5. We are also going to the left from -1. We are going this side. So we end up at what? -6. You just add these two, then put a negative on your answer. So -6, that's on what? That's on A. Or you can just verify on your calculator. All right. -8 over 4 squared minus 4 minus the square root of 64 on 1.3. All right. What can we do? 4 into -8. That's when you divide. 8 divided by 4. This -8 divided by 4. It is going to give us a -2. but it is going to be what? Squared. Remember, there's a squared there. Minus and a minus gives us what? A positive. So that's plus 4 minus the square root of 16, which is what? Which is 8. So we're talking about the number that multiplies itself to give us what? 64. 8 times 8. That's 64. So the square root of 64 is what? Is 8. So this is what you're going to have. Minus 2 squared means you're multiplying minus 2 times minus 2. So minus times minus, that's a positive. 2 times 2, that's 4. So it was going to be positive 4 plus 4 minus 8. So we can have our addition. That's 4 plus 4, which is 8, minus what? Minus 8, which is remaining. And 8 minus 8, that's what? That's a 0. So this is the best answer that you're going to have, which is on what? Which is on A. Or like I said, you can verify this on your calculator. Minus 8 over 4 as it is here. All right. We square this. Minus, we open bracket, minus 4 minus the square root of 64. As it is, your answer, that's a 0 there, all right, which is exactly what we have. All right, which number is equal to a to the power of 0? Any number to the power of 0 is equal to 1. So the best answer is going to be on what? On C, where we have a 1. All right, 1.5. The general term of the sequence that we are given here is what? All right, so here, guys, if we check, that's a numeric. If we check on our terms T1, T2, T3, that's a common difference. Let's subtract 4 minus 1, that's 3. 7 minus 4, that's a 3. So we can see that we have a constant difference or a common difference in this case of what? A 3. So that's under our numeric Tn is equal to Bn plus C. That's a linear sequence that we have. So it's going to be in this manner. All right. So B represents the common difference, or you can even put a D here, or you can put a B, whatever letter that you want. All right. As long as you understand what this represents, this is our constant difference, which is what? Which is 3. So that's Tn is equal to, in place of B, we're going to put 3. So that's 3n plus C. You must calculate or determine the value of C from any of the terms that you're given. For example, T1 is equal to what? T1 is equal to 1. So what it means is that n, that is Tn, n is equal to, when n is equal to 1. So in place of n, you are going to put 1. 3 times 1 plus C. But that Tn, which is T1, is equal to what? To 1. So that's our Tn, which is what? Which is 1. So we can solve for C. That's an equation. Solve for what? For C. Remember your equations from grade 8. That's going to be 3 times 1, which is 3 plus C. So what we need is to take 3 to the other side. That's going to be a negative. 1 minus 3, which is minus 2. So minus 2 is equal to C. So we are going to substitute this in place of C in this part here. Remember, that is where we substituted our n, which is 1, and our Tn, so that we can calculate the value of C. So therefore, we are going to substitute on that part. So therefore, our Tn was going to be written as 3n plus C. So that's plus, our C is what? Minus 2. Plus and minus, that's a minus. So this is our Tn. 3n minus what? 3n minus 2. And 3n minus 2, we have it on what? On D. This is where we have got 3n minus 2. All right? So that is it. 5 marks for that. Let us move on to the other part. which was question number 2. Find the LCM of 36 and 63. So in order for us to have the LCM, we're going to need the product of what? Of prime factors of these numbers. Prime factors, remember the smallest prime factor is 2, followed by 3, 5, 7, 11, and so on. So let us have our numbers. 36, the smallest number, the 2 is going to work. So we are dividing 36 divided by 2. That's 18. 2 again can work. 18 divided by 2, that's a 9. We cannot use 2 here, so we're going to move on to 3. All right, 3, 9 divided by 3, that's a 3. So this is going to work. So we're going to have another 3. 3 divided by 3, that's what? A 1. So meaning to say 36 can be written as a product of its prime factors as 2 times 2, which is 2 squared. 3 times 3, which is 3 squared. All right. What about 63? 63, the same thing. The smallest prime number. 2 is not going to work. All right. 63 divided by 2, that's going to give us this. So we're not going to use this decimal. We need a whole number from that one. So this is not going to work. So we move on to 3. As we can see, 3 is going to work. 63 divided by 3 is what? 21. So you're going to use 3. So 63 divided by 3, that's 21. Again, we can use a 3. 21 divided by 3, that's a 7. We cannot use 3 because 7 is already what? A prime number. So we're going to use a 7 here. 7 divided by 7, that's a 1. So 63 can be written as 3 times 3, which is 3 squared times 7. All right. So this is what we are having from our numbers. So therefore, the LCM, remember the LCM, it is a multiple. This one, lowest common multiple. We must consider every term, every number that is given. But if we have a repetition, we take the one that has got the highest power. The highest power. But we must take every term. Every term. So 2, it has appeared. We must take that one. Even though we do not have any other part with 2, the moment that it has appeared, we must take that one. 2 to the exponent of 2. 3, we have it. But it is of what? The same power. As you can see, same power. So we're just going to write 1. We do not repeat that part. So that's 3 squared times. We also have a 7. Even though we do not have it on another part, we must take everything that we see. So 7 also. So that was going to give us 2 squared. That's 4. 2 times 2. 3 squared, that's 3 times 3, which is 9 times 7. So this was going to give us 252. If you multiply properly, you can just use your calculator. 2 squared times 3 squared times what? 7. This is 252. So this is our LCM. All right. In case the question wanted you to calculate the HCF, the highest common factor is supposed to be common throughout. So 2 cannot be taken. It is not common. 7 is also not common. But we have what? 3, which is common, and it is of the same power. So it was going to be 3 squared, which is 9. Let's say they wanted you to calculate the HCF. That was going to be your HCF. But in our case, they wanted what? The LCM. All right, let us move on. On 2.2, we are given the international call tariffs of a certain company are given in the following table. The number of minutes versus the total cost. So 1 minute, that's 1 rand 50. 4 minutes, 6 rand. So as we can see, as the number of minutes are increasing, the total cost is also increasing. That is what is happening here. An increase in time, an increase in the cost. So the question here on 2.21 is the proportionality direct or indirect? Why are you saying that? Guys, we can see that the time is increasing. There is an increase here. The cost is also increasing. What is that type of proportionality? That's a direct proportion when both are increasing. But if one is increasing and another one is decreasing, it becomes an inverse. So this one, it is what? A direct proportionality. The reason being that both quantities that we have are increasing. There is an increase in both. There is an increase in what? In both quantities, which is what? The number of minutes. Number of minutes. And what? And total cost. And total cost. As one is increasing, another one is increasing. That's a direct proportion, all right? So as we know that it's a direct proportion, now we are being asked to calculate the value of x and y. All right, remember our direct proportionality concept, guys. In this case, we are simply saying, all right, let's consider here. We can take one corresponding to what? The total cost. The number of minutes. 1 minute corresponds to the amount 1 rand 50, which is our amount there. It corresponds to 1 rand 50. So we can ask ourselves on this part of 9 and x. The number of minutes is 9, but we need to calculate x. We do not know x. 9 corresponds to x, just like 1 corresponds to this. So what is the value of x? Remember, direct proportion, you cross multiply. If it is a direct proportion, you cross multiply. The inverse or indirect is the one that you take along, but this one you cross multiply. So meaning to say 1 is going to multiply x. 1 times x is equal to 9 is going to multiply 1,50. So it's 9 times 1,5. You can put a 0, no problem. 1 times x, that is x. 9 times 1,5. 9 times 1,50, that's what? 13,5. So this is 13,5. Remember, x represents the total cost. So that's 13,50 rand. You must have same presentation, 2 decimal places. You are dealing or you are working with what? Money, the total cost. So that's for x. For y, you can do the same thing to calculate the value of y here. You can do the same thing if 1 was corresponding to 1 rand 50. What about this condition? Y here is the one for the number of minutes. So y corresponds to what? To 30 rand. Y corresponds to 30. So what is the value of y? This is not going to change. You are still working with a direct proportion. Cross multiply. So you're going to cross multiply 1 and 30, y and 1,5. 1,50, you can ignore that 0 there on your calculations. So it's going to be y times 1,5 is equal to 1 is going to multiply 30. 1 times 30. All right. Y times 1,5, that's 1,5y, which is equal to 1 times 30. That's 30. So as you can see, this is now an equation. we are now dealing with an equation where you must solve for y. So you simply have to divide. This is a product, so you divide to get rid of 1,5. So that's y is equal to 30 divided by what? 30 divided by 1,5, that's 20. So y is equal to what? Y is equal to 20 here. All right, so that is it. Let us move on 2.3. We are given that the car is traveling at 100 kilometers per hour. Thus, we are given the speed, 100 kilometers per hour. How long? That is the time it will take to travel what? A distance of 300 kilometers. How long? That's the time. So you can use our DST concept. Remember, what we need is the time. So time is distance over what? Over speed. Distance over speed. Our distance in kilometers. Speed is supposed to be kilometers per hour, so that the time will be in what? In hours. So that was going to give us what? 3 hours at the end. All right, just like that. We have our time. Then another question, 2.4. We are given that Carol or Carol, I don't know the way that you pronounce it, invests 18,000. The money or the total amount invested, that was invested into the business or that was taken into the bank, it was 18,000. That's our principal. Money invested. For 6 years, the number of years can be represented by T or by N, depending with the formula that you're going to use. So I'm going to use 6. I'm going to use N for the number of years at a rate of 15% per annum per year, compounded what? Annually. That's a compound interest that you're going to use. So remember that I is equal to R over 100. So that's 15 over 100, which was going to give us 0,15. So that's I there as a decimal. Just divide by what? 100. You can use the formula with R. Remember, it's compound interest. A is equal to P into 1 plus R over 100 to the exponent of N or to the exponent of T. Or we can use the formula A is equal to P into 1 plus I to the exponent of N for a compound interest. So depending with the formulas, if you are given, sometimes like this question paper, we're not given. So you use any formula, all right? I'm just going to use this one to calculate the accumulated amount. What will be the total value of Carol's what? Investment after 6 years. That is the accumulated amount after the number of years for that investment. But remember, it is under what? Compound interest. So you can use any of these two formulas. Like I said, I'm going to use the last one. Amount is equal to P into 1 plus I to the exponent of N, where P is the principal amount invested, 18,000, into 1 plus I, there is what? A decimal, 0,15, to the exponent of N, the number of years, 6 years. So it's all about you and your calculator. We can calculate the accumulated amount or the total amount. 18,000, open bracket, 1 plus 0,15, like this. Then to the exponent of 6, you press this X to the exponent, this one. So you press a 6. So this is what you're going to have. And you must round off to 2 decimal places. Shift, set up, fix, you press 2. So that's 41,635,09 to 2 decimal places. So that is our accumulated amount at the end of the day. All right. So you see, guys, it's just direct. You've explained each and every part: simple interest, compound interest, hire purchases. So go through the introductions. All right. Each and every video is available so that you understand. All right. As part of our whole numbers, remember they include questions also under exponents, this and that. We are asked 3.1, simplify the following. All right, so here let us just expand the brackets, guys. 2 times minus 3, that's minus 6. A times A is A squared. Minus and a minus, that's a positive, 5A. These two cannot be added. These are unlike terms. We have got different exponents. This is 1, this is 2. Unless they are of the same exponent. But as it is, you cannot simplify further. All right. Here we can simply divide. Minus 20 divided by 4, that's a minus 5. Then here we've got D and D, same bases. Subtract the exponents. So it's going to be 5 minus what? Minus 2. X to the exponent of m over x to the exponent of n is going to give us x to the exponent of m minus n. You subtract the exponents. So that's 5 minus 2. So that was going to give us minus 5. 5 minus 2, that's what? That's a 3. So that's minus 5d to the exponent of 3. Let us move on. On this case, we just needed to expand the brackets. 2 times 4, that's 8. A times b squared, that's ab squared. All right. Plus and a minus, that's a minus. 3 times 2, that's 6. A, b times b, that's going to be what? B squared. Everything over what? 2ab squared. Are we seeing, guys, that these are like terms? ab squared, same term, same power. B squared, a and a. So you can subtract, since they are like terms, 8 minus what? 8 minus 6, which is 2. So that's 2ab squared over what? The denominator as it is 2ab squared. Are we seeing that these terms are exactly the same? So they can cancel each other. And you have 1 over 1, which is what? Which is 1. Just like that. All right. 3.4. You just needed to expand. All right. Minus 3x squared. Here we have to expand minus when raised to an odd number. It is going to remain as a negative. So that's going to give us a negative 2 to the exponent of 3 is 2 times 2 times 2, which is what? Which is 8. Y is also raised to the exponent of 3. So this we can multiply, guys. This is simply times. Minus 3 times minus 8. Minus times minus, that's what? A positive. 3 times 8, that's going to be 24. X squared y to the exponent of 3. Remember, negative times negative is what? A positive. Just like that. All right. 3.5. The cube root of 64 minus the square root of 25. The cube root, all right? There's a minus here. So you're going to have minus the cube root of 64. The number that multiplies itself to give us 64, that's a 4. Or you can use the calculator. The cube root, all right, let's first get to the normal mode. The cube root, you press this of 64, that's what? That's a 4. So, but there's a minus which was already there. So it's going to be minus 4. Minus the square root of 25, which is 5. The number that multiplies itself to give us what? 25, that's 5. So minus 4 minus 5, that is going to give us what? Negative 9. Just add these two and maintain the negative sign on your answer. Remember, -4 is here, so -5, we are going to the left. So we end up at what? -9. Just like that. So that was our question number 3. Then question number 4, simplify. All right, 4.11. There's an exponent of 2 here. So that's 3 times 2 to the exponent of 2. That's 2 squared. 2 times 2, which is what? Which is 4. Y to the exponent of 3 to the exponent of 2. Remember, an exponent, you multiply them. So that is 3 times 2, which is what? Which is 6. So this is what you're going to have. 3 times 4, that's 12. Y to the exponent of 6. You are done. All right, let us move on to another one. Here, simply divide 6 divided by 3, that's a 2. A cubed and a squared, you subtract exponents. Remember what I said? When you're dividing same bases, you subtract exponents. 3 minus 2. This is b to the exponent of 1. So it was going to be b to the exponent of what? Of 5 minus 1. So this is 2. 3 minus 2, that's a 1. 5 minus 1, that's a 4. So this is it. Any number to the power of 1 remains as it is. So it's going to be 2a, b to the exponent of what? Of 4. Just like that. 4.2. Calculate the value of this 4.21. 2 times 3 squared. All right. What is 2 times 3? That is 6. So we've got 6 squared. 6 times 6, which is what? 36. All right. 4.22, 5 to the exponent of 6 divided by 5 to the exponent of 3. We are back to division. We subtract exponents. 6 minus what? 6 minus 3. So that's 5 to the exponent of 6 minus 3. That's a 3. And this is going to give us 125. 5 times 5 times 5. 5 times 5 times 5. Or just use your calculator. 5 to the exponent of 3. That's 125. All right, this is addition. 2 to the exponent of 3, that is 1 over 8. All right, sorry, that's 8. Sorry, that one is just going to give us 8. 2 times 2 times 2. 2 times 2, 4 times 2, 8. Plus 2 to the exponent of minus 3, that's going to be 1 over. Remember, 2 to the exponent of 3 is what? Is 8. So that's 1 over 8. So we are adding a whole number to a fraction, guys. Simply combine that. This is a proper fraction. Simply combine them. So it's 8 and what? 1 over 8. All right. 2 plus 3 to the power of minus 2. 2 plus 3 is what? That's a 5. Raised to the power of minus 2. So it simply means we're going to get rid of a negative 1 over. To get rid of a negative 5 squared. So that's 1 over 5 squared, which is what? 25. So that was going to be our 5.24. 1 over 25. Then moving on to question 5, study the pattern made of what? Of matchsticks. So we are talking about these matchsticks and answer the questions that follow. So you can see pattern 1, there are 3 of them. Pattern 2, they are now 1, 2, 3, 4, 5. They are now 5. Here there were 3. Here there are 5. Here they are now 1, 2, 3, 4, 5, 6, 7. There are now 7 of them. All right. So that is what you have. Then here the question was actually draw pattern number 4. All right. This is pattern number 3. So pattern number 4, guys, I'm not going to draw it. I'm just going to use this one. That is going to be your pattern number 4. You remember this one, when you had this triangle, you had to draw this one. This is where you are, this triangle here. So we have to add another one. We're just going to add another triangle. This is going to be straight. Another like this, we add it like that. So that was gonna be our pattern 4. All right, that was gonna be our pattern 4. All right, so you add this part only, that is it. Describe the pattern in your words. All right, as we can see here, there were 3 sticks. Here there are 5. Here there are 7. For pattern 4, the one that I added, this one, there were going to be what? 9 of them, because this is, we just added 2 sticks. There were going to be 9 sticks. So what is happening? From each pattern, there is a difference of 2, So we are simply adding 2 sticks to the previous pattern. All right, add 2 matchsticks to the what? To the previous pattern. To the previous pattern. That is the condition. To the previous pattern. We started with 3, 5. So there's a difference of 2, a difference of 2. The other one is 9. So you're simply saying 5 plus 2, that's 7. 7 plus 2, 9. 9. The following one is going to have 11 plus 2, 13, and so on and so on. So that was the condition. Then 5.13, write down the general term of the sequence in the form Tn is equal to. All right, remember guys, we already saw that there is a difference of 2 throughout. There is a difference of what? Of 2. So this gives us what? A numerical sequence, which is actually a linear sequence that you are dealing with, or a linear pattern. So Tn is equal to Bn plus C, or you can use Dn plus C, where B is the constant difference, that 2, 2, 2 that we see. That's our constant what? Difference, which represents our B. So we're going to substitute 2. So that's Tn is equal to 2n plus C. To find C, we can use any of the terms. The first term corresponds to what? 3 sticks, 3 matchsticks. So it means T1 is equal to 3. The second term corresponds to what? To 5. T2 is equal to 5. The third one to 7. T3 is equal to 7. You can use anyone. So I'm going to use the first one. T1 is equal to what? Is equal to 3. If T1 is equal to 3, it means N is equal to what? To 1. When N is equal to 1, T1 is what? Is 3. Tn is 3. So we can solve for C. So that was going to be 3 is equal to 2 times 1. That's 2 plus C. Take the 2 to the other side. 3 minus 2, that's a 1. So C is equal to 1. So substituting here in this, Tn is equal to 2n plus C. It means therefore Tn is equal to what? 2n plus C. Our C is what? Is 1. So this is what you're going to have at the end. That is it, guys. Just play around. So 5.14, without drawing the figures, determine the number of matchsticks needed to build the 17th pattern. So what we are given there is the value of n, the 17th pattern. N is equal to 17. So what is T17? T17, simply substitute that in Tn. In place of n, you put 17 in place of n. So that's 2 times 17 plus 1. All right, 2 times 17, that's 34 plus 1, which is going to give us what? 35. So we are saying in the 17th pattern, there are 35 matchsticks that we are going to have. Just like that. All right. This one, 5.2, we are given to use the rule. All right, that is given here. The rule for finding output and input values of on the table below is this one. Complete the table and write down the missing values. So you have to find A, B, C, D, E, and so on. All right. So we're given the rule Tn is equal to minus 2n plus what? 2. So the first one, n is what? Minus 2. What is the value of a? So a is the value that corresponds when n is what? Minus 2. So we simply substitute. In place of n, we put minus 2. So that's minus 2 times minus 2, that's 4. Positive 4 plus 2. So that's going to give us 6. So a is equal to what? To 6. Moving on to b, our n is what? 0. So in place of n, we are going to put a 0 here. That is where we are. N is 0. So minus 2 times 0, that's 0 plus 2, which is 2. So b is 2. C, we do the same thing. N is what? Is 4. So in place of n, we are going to put a 4 in place of n. So minus 2 times 4, that's minus 8 plus 2, which is minus 6. So C is minus 6. But this now is different here because we are given the value of, we are given Tn. So Tn is the one that we are given, which is what? A 0. So that's 0 is equal to this part, minus 2n plus 2. So we are going to solve for n. D represents what? Represents n. So let's solve for n. Take it to the other side. It's going to be a positive. 2n is equal to 2. So we can divide by 2 by 2. So n is equal to what? 1. 2 divided by 2, that's a 1. So D is equal to 1. That's the same thing on this part. Tn, sorry, it is actually different here. It was just for D. The other one, we are back here where we are given n is equal to what? N is equal to 8. So when n is equal to 8, you go back to this, our Tn here. N is equal to what? N is equal to 8. You substitute your n, which is 8. So that's minus 2 times 8, minus 16 plus 2, which is going to give us minus 14. So this is minus 14. So these are the values. A is 6, B 2, C minus 6, D is 1, E is minus 14. You just use the relationship, the way that you are given, substitute properly into that relationship to calculate whatever that you're being asked there. So those are the typical questions. Make sure that you do revisions. All right, work out as many question papers as you can. Like I said, they are going to repeat most of the questions, asking them in a similar way. Some of these ones they are going to repeat as they are. So do more question papers. All right, do more question papers so that you understand how to attempt them in different ways. So that is it till we meet again.